the track that we have here. So my name's Frank. I'm based in Rakuten's San Mateo, US headquarters. I'm in charge of software system enablement department, and one of our core technologies that we work with is actually the API endpoint technology, which powers Rakuten's apps. And so I'm really happy to introduce Marco, and his co-founder Augusto is also here as well, from recently renamed to Kong, used to be called Matchshape. And they're going to present a lot about the API revolution and all the really great stuff that they're doing. So without further ado, Marco.
Thank you, Frank. Honjin-swa, oide, itadakimashite, arigatou gozaimasu. My name is Marco, so thanks for coming here at this talk, and I'm honored and happy that Rakuten had some time for me to speak about APIs. APIs, which is this word that's really changing everything in how software is being built and consumed. My name is Marco. I'm the CTO at Kong. Kong is an API gateway. It's a system that sits on the execution path of all of these API requests and allows you to protect them, secure them, transform them, and so on and so forth. You know, a few days ago, I was talking with a person, and this person was like, Marco, how would you call an API in very simple words, right? And I remember this other person telling me, an API, it's like sitting in a restaurant at a table, and you're ordering some food. And now the food, it's in the kitchen, but you are at the table. The waiter takes your order, goes back to the kitchen, picks up the food, and brings it back to the table. And the waiter is the API. Now imagine this restaurant with 1 million tables and 1 million waiters. Now imagine everybody making orders. How does the chef really know if the waiter is authorized to make this request? How does the waiter really know how to stop these requests if they're coming too fast? And so the API gateway, it's a middleman that sits on your API infrastructure and allows you effectively to authorize, authenticate, and block all of these API requests. Kong, it's located in San Francisco, but we do have, so this is the team in our San Francisco office, but we do also have offices around the world, in Asia Pac, US East, Europe as well, and we're a very distributed team. When we think about APIs, really we're thinking about something that has shaped how software is being built over the years. You know, APIs as a concept, it's not a new word. APIs have always been existing. But APIs, over the course of the past 2 decades especially, have continuously evolved to become the primary technology at the center of your organization, of products, any product per se. You know, APIs started, you know, the mainstream HTTP APIs started with SOAP, with XML, and then they have evolved over time to support other protocols and other technologies, and they became simpler and simpler to consume. And so then we had RESTful APIs based on top of HTTP. And then from there, we're still evolving what API means inside of our infrastructure. And now we have, for example, microservices and RPC. So let's take a step back. How do really APIs shape how we build our software and shape how we consume our software? Well, if you remember in 2007, there was an explosion of mobile apps. The iPhone comes out, and now everybody needs to have an API in order to communicate with these mobile applications. We need to have an API so that our devices, our web pages, our partners, they can now interact with our software and make requests and share data with our software. These APIs were primarily being used as public APIs. You know, we have a public developer community, or we have a public use case, we have a public mobile app, and we need to access the data that's behind the firewall. So how do we do that? Let's build an API. And then as our software becomes more and more complex, as we onboard more and more clients, more and more partners, as our ecosystem grows and changes, APIs evolve with this new adoption. APIs become, first of all, homogeneous, distributed everywhere, and they become kind of a software answer to more and more complex demand. And so we see that in 2014, really there is an explosion of RESTful APIs, and the reason is, in 2013, a year before, Docker came out, and Docker and containers really gave to everybody else the tooling to adopt APIs at a massive scale. inside and outside the organization. You know, when you think of APIs, we're looking at external use cases first, but then as they evolve, APIs become increasingly important at the core of the organization, at the core of your internal services. APIs are not being used externally anymore. They're increasingly being used internally as a way to enable other teams, other departments to start working together. In 2013, Docker came out, containers came out, and APIs exploded everywhere inside of the organization. You know, some companies before Docker, before 2013, had very progressive teams and have done this transition a lot earlier. Think of Netflix. You know, there wouldn't be any Netflix without an API. There wouldn't be any Amazon or AWS without an API. There wouldn't be any of this. And then the tooling was lacking. And so everybody else was like, okay, yeah, but how do we do this? How do we approach this transition? And then Docker, containers, a new ecosystem exploded. And it's really shaping how software is being built. What I'm seeing when I talk with developers, with communities, when I talk with organizations, even with our customers, we're seeing this massive transition and adoption from SOAP to REST, from monolithic to microservices, and everybody's doing it. Everybody. APIs, again, are important because they allow web applications. Think of your HTML5 applications, you know, WebSocket, to consume those systems through an easy way, an easy interface, but as well as partners, as well as other internal services. Internal services that are built by you, that are built by other teams, by other departments, that's really, it's creating a mesh of services inside of your organization. But then again, there is more and more evolution around the APIs and how they should work together. And we're also seeing the adoption of new technologies. Think of serverless, think of functions as a service. This world is rapidly evolving. All of this is changing as we speak, right? And there's going to be some consolidation moving forward, but as of today, there are lots of use cases that developers, that companies, that your software is trying to implement by using these APIs. So let's talk about SOAP. You know, APIs, it's not a new word. APIs have always been existing, right? In one form or another. We used to have COM, we used to have Corba, and then those were very hard systems to consume. And so SOAP came out. And when SOAP came out back in the days, it was actually revolutionary. You had a very easy way now over HTTP using XML to consume third-party APIs and services. SOAP was primarily being offered by monolithic applications. So we don't have that explosion of microservices behind the firewall just yet. But SOAP was a great way to enable partners outside of the firewall to start making those requests, to start consuming your services, to start making orders to the chef. But it was very hard to consume, and especially in the context of HTML, HTML5, and JavaScript and web technologies, that was very painful. JavaScript doesn't really provide it back at the time. XML, easy to use XML parsers. SOAP, it's very chatty, it's very heavyweight in a way, and it's hard to read. XML, it's not human readable, it is complex, you have attributes, you have values. Something else can be done to simplify how all of this works. And so as a natural evolution to SOAP, we have REST. Everybody remembers how REST became the #1 keyword for APIs. Now you can easily parse your APIs with JSON parsers, which by the way are first-class citizen in client-side technologies like JavaScript. We can easily now consume those APIs and build community around those APIs. We can integrate very easily with JavaScript. We can lower the bandwidth that's being consumed by these apps by having a more compact format, which is JSON, between all of these different services. And most importantly, REST was following the best HTTP practices. If you put a caching layer in front, well, it still works. The API becomes like a web page. You don't have HTML, you have JSON. But all the principles, all the tooling around HTTP could still be reused with these RESTful APIs. But at this point, really, APIs are still being used and exposed by monolithic applications. A monolithic app, it's a very large app, a very large code base with everything baked in one place. If you want to build a new feature, if you want to scale your system, you have to redeploy this app all the time. You cannot deploy a module, you cannot deploy a single component, you always have to deploy the entire thing over and over again. Of course, this creates problems for larger projects. Monolithic, it's maybe a great way to start. If you're small, you need to push something out. But then as you grow bigger and bigger, you want to have a team that can independently work with each other, a team that can independently scale and experiment with new features and new technologies. And monolithic apps are not a good fit anymore. They're too big, they're too large, and learning how to use a monolithic code base, it's increasingly harder because it's just too much code, too many moving parts, all in one place. And so, when we talk about 2007, 2010, we're still talking about primarily an edge use case. So we have our monolithic app, and APIs sometimes were even not built as part of the monolithic in the first place. They were an addition, an afterthought that you built after to communicate with those services, communicate with those mobile applications. And so API management also back then was something that was staying on the edge of your infrastructure, at the edge of your organization. But then we decided that that was not worth it anymore, and there is a better way of doing stuff. There is a better way of decoupling these monolithic applications. Somebody said, going from monolithic to microservices, it's like going from a chicken to a chicken McNuggets. You are decoupling your monolithic, and you have to keep the chicken alive during the process. It's a very hard task. So this is the biggest transition that every enterprise I'm talking to right now is doing. Think of banks, think of governments, think of telcos, finance institutions, e-commerce. All the enterprise, all the top global 5,000 are now doing this transition, decoupling their monolithic into microservices. And they're doing it with different strategies, of course. Not every strategy works for everybody, but sometimes they're just keeping the monolithic in place and building new features as microservices. Some other times they decide that they want to extract from the monolithic individual components that can now live separately. Each one of these components now can be scaled independently, can be developed independently, and APIs are increasingly being used inside of the network. Now, this is a big shift, and it's revolutionary in my opinion, because APIs are not being used just as an external way to communicate outside of your organization. The topology of your traffic, it's increasingly moving inside your firewall. Microservices are small unit of executions that by themselves, they provide one simple service, but when put together and consumed together, they can provide a fully featured application. Now you have pizza teams that are very small, 8 people, not large teams anymore, that can work independently. They can play with different technologies. They can play with Go, with PHP, with Ruby, with Java. It doesn't matter, as long as the API interface, it's easily understandable and can be easily consumed. This transition from monolithic to microservices, it's not just a technological transition. Containers made these available because containers provided a very easy way for organizations to deploy and scale and run these components. Think of Kubernetes, think of Mesosphere, all of those open source tooling and tools which allows you to be successful with that scenario, with that transition. Open source, it's leading this transition. And this is a very big change if you think about it. Open source has never been adopted and acquired and put in production as much as this decade by the enterprise. SOA, SOAP, was pushed by vendors, but microservices, decoupling your APIs, it's being adopted by developers. It's bottom up, it's not top down anymore. Open source, Docker, Kubernetes, Mesosphere, you name it, are leading this transition. It's not just technical, it's organizational as well. When you're going from the left to the right, you are rethinking how your teams are working with each other. You are rethinking how the communication between your teams is happening. You don't have one code base anymore. You don't have one team anymore. The onboarding process, all of that, it's now changing. It's an organizational change alongside being a technical change. And the role of the gateway as well, it's important as well. Now you have these moving parts that are all across your organization. You need to have a way to easily discover them. Therefore, service discovery. You need to have an easy way to authenticate them. Therefore, you have OpenID Connect, you have like HTTP authentications. Or you need to make those APIs easily consumable by web applications. Think of Course. The gateway now provides you that abstraction layer that can sit on top of this complexity and provide an easy way to consume these APIs. It's really changing how we are thinking of all of this. It's It's not, if you think of microservices, you're not thinking of smaller monolithics deployed across your organization. You're thinking of individual components that cannot exist without another component. You're not thinking just of having a centralized layer which manages all of this for you. You're now thinking in a decentralized and distributed way. When you think of traditional HTTP technologies or gateways or caching layers, you usually think of an extra hop in the network. Okay, we have an API. Now we need to accept other people to consume this API. Let's put this additional layer in our architecture so that we can allow and make this happen. An extra hop in the network. Problem is, latency with microservices becomes a #1 requirement in a sense that we need to cut it, we need to remove it. When you have a monolithic app, it doesn't really matter if this has 50 or 100 milliseconds of latency. I mean, it does matter, but it's not that critical. With microservices, you have lots of back and forth between these microservices, and if you have 10 or 50 milliseconds of latency, it will compound over time, and you end up with half a second of latency, 1 second of latency. That's not acceptable anymore. And because of that, new patterns are emerging and evolving. Think of Kubernetes sidecar. We're running sidecars alongside our microservices so we can cut that latency down. Think of Uber, decoupling the monolithic in different services so that now their team, they have like thousands of microservices, more than that. They can now easily deploy and scale them across the world. And really, when you have microservices, you're thinking about having an infrastructure in place which allows you to be successful with it. It's like running a city in a way. Think of it. You have all these services, you need to communicate with each other, you need to protect them, you need to secure them, you need streets, you need roads, you need freeways, you need police departments, security, you need fire departments, you need all of that in place for you now to be successful. The way we're building this, our software has radically shifted and changed, and so we need new tools now in this new era of microservices to be successful with it. The older tools, the older monolithic tools, are not good anymore for us. And as a matter of fact, a new pattern is emerging. Think of Docker, Kubernetes, Prometheus, Open Tracing, Google RPC, Mesos, and so on and so forth. These are all new technologies that are helping you building software in a significantly different way than used to be before. The open source, it's shaping the enterprise. Developers are adopting these solutions, and then they go to production, and then they push the urgency of having a better strategy, a global strategy for your organization up the ranks. Open source, it's the key word of this decade. Open source, it's shaping how software is being built in a very radical way. When we think of the future of microservices, the future of APIs, and how our clients interact with those APIs, we can even go farther. When we think of microservices, we think of a service-to-service communication. I have service A that wants to communicate with service B. Let's open a connection. But then there is a new pattern that's also emerging. By using, for example, a log collector like Kafka, if I need to change the state of my data, I don't want one service to talk directly to another service because that communication can be broken, can be interrupted. Maybe the service is not available today. So how do I do this? Well, how about I push an event into a queue and then asynchronously that service picks up these events from the queues and then changes the state. Think of an order and invoice system. Every time there is a new order being created here, an order created event is being pushed into, for example, Kafka. And then the invoice microservice can asynchronously, when it has time, pick up that event and create the invoice. You have consistency across your use cases. And really, this is a new way, again, that APIs and your infrastructures and your services are taking for building more complex and advanced systems. We went from SOAP, primarily edge use case, to REST. It's like SOAP, but it's easier. And then, monolithic, it's not good anymore. Let's decouple those in microservices. Let's use some RPC or some JSON internally. And then guess what? That's important and works most of the times, but if you have to change the state, maybe we can use a log collector to help us, propagating this information. And really, this is alternative approaches to building microservice-oriented applications that are being experimented right now. This entire space is rapidly evolving. And as a matter of fact, we do have an explosion of services. So this is the landscape from the Cloud Native Computing Foundation. All of these tools, each one of these tools, most of them, were born in the past few years. This did not exist before. This did not exist back in 2010. These are all new tooling which will help us be successful with this microservices world. And guess what? Not all of these will stick around. Eventually they will consolidate. Eventually some of them will become more popular. Some of them will disappear. And a new stack, a new pattern will emerge. And of course, if our applications are changing, if the core of our infrastructures are changing, that also means that our clients will also have to change. Clients that were external, now they can be internal. Web technologies that are evolving to accommodate more complex requirements. Think of real-time, WebSockets. Think of instant feedback loop across your services. Arigato gozaimashita. This is a very complex topic and there's lots of changes that are happening. If you have any questions now, I'll be happy to answer them. Or you can just meet me around the conference, the tech conference. I'll be happy to share a chat with you.
Cool. Any questions? I think we have a couple, like 1 or 2 questions. Maybe I'll just transfer this thing. Oh, you have. Anyone have any questions? Yeah. Does it work? No? Okay, I'll follow. Yeah.
So with the HTTP2, like the transmission has become binary and it's a single TCP connection. And with the advent of gRPC, and what do you think is gRPC plus HTTP2 is far better than REST plus HTTP2? Or how do you make the trade-off?
This is a very good question. As I mentioned before, microservices have a stronger latency requirement. We need to cut the latency down however we can because it will compound over time. And so using HTTP2, it's a great way of doing that. It's a binary protocol as opposed to having a textual protocol like HTTP 1.1. Now, Google RPC and protobufers and HTTP2, they effectively cut down the transmissions length of the communication between your microservices. So it is a good way of building your microservices inside of your network. But then if you do have external partners or teams or applications that have to consume those APIs, you might want to leverage the existing HTTP stack. And so you might want to have a translation layer that goes from HTTP JSON REST to then Google RPC. So it's a very interesting question. I would say it depends where the client is. When we think of the edge used to be the edge of our organization, but now the edge, it's the edge of our department, it's the edge of our team, right? So inside of that department, you might want to leverage Google RPC, but when you start making those APIs available to other partners or departments, that's when you maybe want to have an easier to use layer like HTTP.
Cool. Okay. I think we're over time. So thank you very much, Marco.
Thank you.